Hello everyone. Today we will be seeing module 3 which is on principles of wiring and fixation. So we'll be introducing with the maxillomandibular fixation. In this, we have to stabilize the fracture segments. Wires are passed interdentally between teeth in both the jaws, followed by tightening of these wires together in a crisscross fashion, which will serve to stabilize the fracture segment. Then we'll be seeing the armamentarium and principles. We will use our stainless steel wire around the diameter of 0.35 to zero point 0.5 millimeter, and it is utilized and which is pre-stretched to 10% of its original length to prevent loosening of wire once it is tightened. Overstretching beyond this point should be avoided as this will make the wire brittle and susceptible to breakage. Then we will be seeing the basic principles of wiring, which is continuous tension on the wire while twisting and tightening. Force should be apically directed while tightening. Utilize a clockwise direction for all tightening or twisting. Only a half turn to be given at the time of the end. Once the tail is cut, it is turned and placed into the interproximal embrasures. Once all the wires are in place, move the finger around the arch bar or wire to check for any sharp edge or margin or wire ending so that it does not impinge the soft tissues. Then we will be seeing some of the interdental wiring. One of that is Gilmore's direct interdental wiring. So according to the image, we can appreciate that we are taking a wire and we're passing it between the interdental embrasures so that the wire pays buccally. After using the wire twister, we have to twist it apically and then send it inside in the interdental embrasures so that it does not impinge the tissues. Then we'll be seeing the interdental eyelid wiring, that is IV loop method. In this, we have to make the IV loop freehand with the help of any metallic rod, which is around 3 to 4 mm in diameter, and then stabilize the loop with 3 to 4 times of twisting the wire. After this IV has to be taken in the interdental embrasures, and one end of the wire is bring back from the posterior side from the distal end in the anterior direction so that it should face buccally, and same the other end of the wire to be taken from the anterior teeth in the mesial interdental embrasures, and then the posterior wire has to be taken from inside of the eyelid and then it is twisted and secured. Then the arch bar. The indication of arch bar are partially edentulous patient where placement of eyelid is not an option due to insufficient number of teeth. The teeth present are far apart, making alignment impossible. For alignment of avulsed teeth or displaced dentoalveolar fracture into proper arch form, reduction and immobilization of dentoalveolar component or fracture as a part of integrated treatment for suspension for treatment of maxillofacial trauma. So we will be seeing the technique how to fix arch bar. So in arch bar, we are taking pre-stretched wires. Then we are passing the wire interdentally and so that the wire is face buccally. And then we take the arch bar and fix it between that. Then the wires are twisted and tightened. Once it is tightened, it is easily bonded so that it does not impinge the soft tissue. It has to be done on each tooth and then it is fixed with another group of wire interdentally. Then we will see the principle of internal fixation. The following are the guidelines for internal fixation based on four basic principles formulated by Association of Osteosynthesis in 1958. First is anatomic reduction to restore the normal anatomy. Then stable fixation, fracture fixation with relative or absolute stability as required by the patient's injury and type of fracture. Preservation of blood supply by gentle reduction and careful handling along with preservation of vascularity of soft tissues and the bone. Early and active mobilization, rehabilitation of the injured part and the patient as a whole with early and safe mobilization. So these are the four steps to be followed for any internal fixation. Then we have Santi's line of osteosynthesis. It is based on the principle of neutralizing unfavorable traction strain while at the same time allowing transmission of favorable compression forces. So if we put the mini plates or any of the fixation in the Santi's line, it will neutralize the traction and the compression forces. Then we have fixation method and devices. So the commonly used devices used for fixation are wires, staples, pins, and screws. Material used are titanium and stainless steel. Stainless steel has been used because of its better biocompatibility and corrosion resistance. Since 1980, titanium was used in maxillofacial surgery. Example of rigid internal fixation are the use of bone plates and screws or two lag screws or the use of reconstruction plate with three screws on each side of the fractured fragment. Use of long compression plate is also included in internal fixation example. Then we have semi-rigid fixation. In semi-rigid fixation, it is based on load-sharing osteosynthesis. So semi-rigid fixation includes the use of lag screw, mini plates and microplate, blocking plate, resolvable plate, three-dimensional plates. So we'll be seeing a difference between what is load-bearing sharing fixation. So the load-sharing fixation is the internal fixation of inadequate stability to withstand the functional loads across the fracture. And load-bearing is the capable of withstand the entire load applied during the functional activities to the mandible. Indication for load sharing are simple linear fracture and mandibular fracture, while for load bearing it is mandibuloconvoluted fracture, loss of segment of mandible due to injury, fracture with very less bony interface because of atrophy. Materials used for load sharing are stainless steel, titanium, 2.0 millimeter mini plating system. In stainless steel, titanium, 2.3 millimeter, 2.4 millimeter, or 2.7 millimeter diameter, and manual reconstruction plate for load bearing. The complications that can occur during load sharing fixation are due to inadequate bone stock adjacent to committed fracture, so load sharing principle plates should be avoided. And in load bearing, there is failure by either screw loosening or plate fracture. Then we'll see about the lag screw. The lag screw principle is used whenever two wide contact surfaces of the bone should be pressed together, like, for example, mandibular oblique sagittal fracture or only graft fixation. Advantage of lag screw over the bone plates are lag screw required less hardware, hence cost effective. Absolute rigid fixation, quick and easy to use, accurate reduction, which you can appreciate in the image of lag screw, which is a fixation with the lag screw. Disadvantages: lag screw fixation relies on compression of bone fragments, and if intervening bone is unstable due to combination or pressing, there will be segment overriding or fracture gap shortening, resulting in full occlusion. Mini plates. The mini plates vary in length from 2 to 9 centimeter with a thickness of 0.9 millimeter. They come in different lengths, such as 2 hole with gap, or 3 holes, 4 holes, 6 holes, 8 holes, to 16 holes with gap or continuous plate. The 4 hole and 6 hole plates are available with intermediate spacing. There is wide variety of pre-shaped plates like LX, Y, G, Delta, 3D, H plates, which are also available. The mini plate diameter is 2.1 millimeter with the whole of the plate and it has a bevel of 30 degree. Then for mini plate, we need to use a screw. So all screws which is used are cortical, self-tapping and has cruciform head. Available in length of 5, 6, 7, 9, 11, 13 and 15 millimeter. 2 millimeter in diameter of the screw with 1.64 diameter of thread. The screw thread is 10 by 10 so that 1 ton of the screw corresponds to 1 millimeter penetration into the bore. 2.8 millimeter is the screw head diameter and it is designed such that it allows insertion at 30-degree angle with respect to plate surface. The drill has the same diameter as the core of the screw, that is around 1.6 millimeter. This ensures firm anchorage of the self-tapping screws. Then we have plates, which is compression plate and reconstruction plate. In compression plate, we have DCP plates and EDCP plates. We'll see the plates one by one. So we have reconstruction plate first. So the reconstruction plate is a rigid plate, 2.7 mm bicortical screw, which were introduced by AO or ASIF in 1972. Indications for reconstruction plate are large defect of mandible after massive trauma, after mandible resection due to tumors or osteoid necrosis, commonly used in comminuted fracture of mandible, sometimes in combination with mini plates to support the bone graft in mandible reconstruction. You can see the reconstruction plate. Then we have dynamic compression plate, that is DCP. These are the fixation plates designed to produce compression between the bone fragments on the activation. Compression plates produced by DCP is 300 kilopascal by centimeter square or 600 Newton. This compression is less than the compressive strength of the bone, thereby produces no bone necrosis. The compression plate is placed in such a way that two holes lie on either side of fracture line. The screw is inserted in the narrowest part of the bone such that after tightening, its head comes to rest in the wider diameter of the bone. Since the upper border open up during the application of compression, a tension band should be applied at the level of alveolus before tightening of the screw. So you see a tension band. Tension band can be either mini plate or the arch bar. Then we have eccentric dynamic compression plate, that is EDCPs. It is based on the principle of compression oxycenthesis. It differs from DCP in its application in situation where tension band application is not possible, as presence of implanted third molar with angle fracture, edentulous mandibular fracture, or avulsion of bone from fracture site. The advantages are even distribution of forces along the length of fracture. Disadvantage technique sensitive and results are not found to be superior to other fixation methods. Then we'll conclude this topic with that for the treatment of maxillofacial fractures, many fixation methods have been used with great success. Maxillomandibular fixation can be done for the conservative management of such fractures, which can be carried out with the help of arch bars, wiring, and cap springs, and in edentulous patients by running spring. The open reduction and internal fixation can be carried out with the help of mini plates, microplates, 3D plates, and reconstruction plates. There are different plating systems and wiring technique makes the management of these maxillofacial fractures predictable with high success rate. Thank you.